presume it is. Yeah, something about a 420 joke. Obligatory. Cool. Thank you for coming and not going to see the guy that designs C# next door. I feel blessed by your presence. So today I want to talk to you about intentional code. And it's a funny and dear topic to my heart because I know we all often are in this place where we feel like everything kind of sucks. And this isn't a repeat of my keynote session, which was a different kind of everything sucking. But we've all had this experience where you're maintaining some kind of application and you're trying to work out what it does. It's not yours. You've been put on a project and you're peeling away layers of abstraction and layers of libraries and dependencies and package managers and build tools. And the voice in your head is just screaming, why the fuck is this like this? Like, surely it should not be this difficult to do this trivial change that I'm trying to make to some software. And I was a consultant for 10 years, so about everything I touched was a why is this like this moment. So my name's David, and I spend way too much time thinking about software design. It's kind of my toxic character trait. So I work at a company called New Day in London. Obligatory, yes, we're hiring, probably not in Australia, sorry, so not very relevant to this room. But I'm really here to talk to you about why design is important and why everything matters. So I'm a programmer in the sense that you will pry my keyboard out of my cold, dead hands. They will probably bury me trying to commit the last thing I have to GitHub, regardless of the job title they stick on top of it, to be honest. That said, there's not going to be an awful lot of code in this talk. We're going to talk around the theory around the code, because what I really want us to think about is design as a concept as much as programming. So I did a bit of a small viral tweet, those mid-sized tweets that go down well. Recently, that seemed to resonate with some people because I was trying to fix up this objectively awful code base. I was trying to help a team. And I opened it and immediately my heckles were raised upon seeing this thing here. And I did what I always do whenever I see something that makes me sad, and I just opened Twitter and I rage tweeted into the void. I distinctly remember thinking this is like a really damning indictment on the state of a lot of modern application design. And, Twitter mostly agreed with me. But the thing that really jumped out at me from this application design as a layout was how thoughtless it all was, like totally thoughtless. Because the truth is, organizing code by architectural feature is like way up there on the crimes you can commit to your own code bases. Precisely because there is no answer to the question, why is it like this? That there is none at all. So hopefully throughout the session, we're going to cover what the ways that you can answer the question, why are things like this? Because organizing your code by architectural concept is about as meaningful as taking a classic car collection, smashing all the cars apart and organizing it by wheels and windshields and boots and seats. Right? It doesn't look like anything. It's not even a car at that point. So lots and lots of talk about design in software and the form of code always ends up getting dragged back to the work done in the 90s, mostly about design patterns. So this isn't a talk about design patterns either. But I want to pay them a little bit of lip service and due respect before we get going, because it's really probably quite easy to misinterpret what I'm about to say as some kind of tirade against design patterns or like a rallying cry against standards, but it's really not that. So design patterns, often misused, originated in the works of a guy called Christopher Alexander. So he was like an actual real-life architect, like one of the real ones. And he wrote this wonderfully titled book called Notes on the Synthesis of Form. It's like my progressive metal album, I think. So it was read by a lot of computer science researchers in the 70s and 80s, resulting in works by people like Kent Beck and Ward Cunningham in the late 80s and early 90s around pattern languages. So the Gang of Four book here is the most famous example of the patterns books. So that came out in 1994, which is probably the foundational text for most people. And what it did was it attempted to lay out a series of structural, creational, and behavioral patterns observed in common software of the time. So there are a bunch of books that followed. So people like Kent Beck wrote Smalltalk, Best Practice and Patterns. Martin Fowler wrote Patterns of Enterprise Architecture, which a lot of people have read. And ultimately, all of these books existed with the good intention of exactly one thing, which was to provide concrete guidance and a description to common solutions to problems that they had seen recurring. And that's what design patterns really are, right? They're not goals. It's not a thing you're meant to aspire to. They're giving names to model answers to common questions. And when you give concepts names, you empower them. It means you can talk about them. We develop a shared language, and that's like a really, really good thing. So I have nothing but respect for this kind of foundational work around design patterns that help describe like a whole category of common things in our industry. But this isn't about design patterns, because what patterns do is they try and make categories of problems look the same. This is a talk about design when everything else is different, about all the other bits that don't fit. So I suppose I just kind of lament that most talk about software design has devolved into talk of patterns, because they're kind of the least interesting bit. You know, if design patterns are all about the parts of the system that are familiar, with the acceptance that, you know, as we push programming languages further and further on, actually many of these patterns become obsolete over time. It feels like we kind of forgot to talk about everything that wasn't predictable or common, as we got obsessed with kind of these broad structural things. And I think real design really starts where patterns end. So on the other end of the spectrum, we have large-scale architectural conversations around design. So you see things like N-tier and hexagonal architectures and 12-factor apps and all the big organizational patterns kind of come into play. And they often try and offer prescriptive rules around the form of an application. But I think there's probably more axes to design than just functional patterns and large-scale kind of application architectures. And I think the most interesting aspects of design happen in the moment-to-moment interactions of a programmer with the system. So back in the depths of time, I was an art student. I know what I look like. It's fine, I get it. But I literally studied literature and design and fine art. I used to paint in the 90s in high school. And I specialized in literature and politics. And I just always wanted to be a programmer. So I've got these two very, very conflicting parts of my background. And for the first half of my career, I really struggled to reconcile the aesthetic sensibilities of design with, you know, the books of the time, I suppose. You know, I started programming in the mid-90s, and all of the noteworthy works around what good design looked like were these foundational design pattern books. And they were basically saying, hey, this is what quality is. This is the good answer. So I did a computer science degree, like many people after that point. And during the first year, like most comp sci students, I happened across the works of Donald Knuth, you know, the guy that wrote the book that no one actually read, the big doorstop one that isn't finished. And, you know, Donald Knuth, very, very famous computer scientist, literally wrote a book called Literate Programming in 1984. Literally the year I was born, so no new ideas. And what he'd done, actually, Knuth had tried to get traction in this space with the idea that software should be written by combining the idea of a documentation language with a programming language. And the combination of the two would produce comprehensible code that was maintainable by teams. And this is, you know, kind of consistent with the rest of Donald Knuth's output. This is a man that took 10 years out from writing a book to write a text editor to write the book in. So not very surprised, these big on the big ideas. And if you think about it, the programming languages of the 70s, when Knuth was formulating these ideas around literate programming, were a far lower level of abstraction than the common languages used by most people today. They were much more machine-oriented than programmer-oriented. And actually, he was right, in that over the 30 or 40 or 50 years since then, actually we've trended towards much more literate languages that look more like human writing. And the truth is, there was this core idea that really resonated with me, which was software really is the same as literature. It's not just like literature. So it was a bit of a revelation to tiny baby programmer David, who finally had found the way to marry these two ideas together in his head. And it kind of changed the way I started writing code, because I came to this conclusion that software only becomes good, just like literature, if you focus on writing it well. And actually, if we design with that in mind, we can change the aspects and qualities of the code bases that we're looking for. So over the years, I've come back to this really, really precise definition of what I believe software actually is. It's a constrained form of communication between programmer and programmer, describing concepts and problems that almost accidentally happens to be executable by computer. Like it's almost a happy accident that computers can run the stuff that we write. It's an exercise in putting language around a problem space. And the more you think about it, the more it starts making sense. You spend a much larger portion of your time reading code and comprehending code than you do writing it. That's always been true. Your code exists in a context. It has subtext. It has authorial intent. Sometimes bugs exist, which are kind of almost like an unreliable narrator, I suppose, if I'm really going to stretch the analogy. But your code definitely has rhythm and form and flow, just like any other writing. And most importantly, your code has a reason for being. It has intent. There's a purpose. And then there's this, everyone always gets upset when I put this on, and the YouTube comments really, really hate it. Just burn your copies of like Clean Code and other poorly aged books talking about all this stuff. It gets us out of having to deal with problematic people, which is useful. But also, Clean Code was kind of a book that existed in a context in time where maybe there wasn't many good conversations about what quality looks like in software. But the truth is it's an extremely dogmatic book. And the presence in our industry has reduced discussions around quality and to discussions about naming variables. And that's boring, right? It's kind of muted conversations around architectural style in the same way that dogmatic adherence to things like solid has. Its shadow is long and it's kind of a thoughtless dogma at this point. It's useless to us. So everyone always gets really, really upset. I'm like, oh, you can't hate on the book that I love. I don't know, man. I liked that book too at one point and it was fine, but I grew up and sometimes the things that you need to get yourself from A to B is not the same thing you need to get from B to C. I think there was a point in my career where I thought rules around basic hygiene were enough. But over the last 5-10 years, maybe I've come to value intentionality in my code above any kind of idea of syntactic cleanliness. And when people say, what do you mean when you say intentionality? I mean that literally every character you type matters. Everything you type, every key press matters. And I would really, really like people to approach the work as if everything that they were typing was important. The white space matters, the rhythm of your code and the form matters, naming matters, function matters. All of these things are there to telegraph intent. And code written with thoughtfulness and intentionality are really kind of what matter to me. So when you think of your software as literature, it lets you value different ways of communicating in code. So we can communicate at things like at the macro scale with organizational patterns and application architectures. Take, for example, MVC, the classic example. MVC is an organizational pattern mostly. And it dictates how you split up your code. And in most of the common implementations of the pattern, it kind of tells you literally how to organize your application. Now, I have a bit of a love-hate relationship with MVC. And that's precisely because MVC has some positive qualities in that you can look at an MVC app and basically see that it's a website. And it has some negative qualities. You only see a website. When you look at an MVC app, you don't see what it does. The things that it does are not obvious. You see the pattern rather than the implementation or the detail. So it's a good example of an organizational pattern that tells you how an app works without actually telling you why it exists at all. And actually, I find the micro scale a lot more interesting, where the way that you form code on a function-to-function, module-to-module way telegraphs intent. So we use form and flow specifically to increase cohesion in our code base. That's the tool we have. So by way of example, when I say use form and flow to increase cohesion, I want to share 2 screenshots. And this is something from another thing I tweeted from the exact same code base that made me mad. You know the process, right? You're peeling it back bit by bit. And everything you open, you get more angry until you find the thing that really, really takes you over the edge. And here's a benign, ugly function, right? This is not interesting at all. Just some HTTP stuff. But it's really difficult to read. And it's really difficult to read because there is no use of flow or form here at all. And actually, it forces your brain to comprehend each line in total isolation. You're basically turning your brain into a big head computer that's trying to keep the state as you read it through. So we use paragraphs in text to guide the reader, right? We group related concepts before we move on to something else. Code is just the same, exactly the same. Lines mean something. If you use them everywhere or nowhere, you're removing an entire category of expression from your code. Now, this is a really incredibly small-scale example just to prove the point, and it does a kind of an injustice to the effect of code with good form. But code with good form is like poetry with rhythm. It directs the reader. It telegraphs how you're meant to read the code. It shows what's related. I suppose its aesthetic sensibility reflects how the form of control in the software is designed to be interpreted, right? And that's interesting to me. And all we did was deleted some empty lines, right? There's nothing that has actually changed about the code sample. The flow and the form of your code is something you use to communicate intent. It's design. Now, the more I started thinking about software through this kind of lens of literature, through this lens of intent, it became more apparent to me that what I was really reaching and reacting to was the inherent complexity we see in a lot of software that we build today. We've got very, very big tool chains that are very, very complicated most of the time. And I was kind of craving this clear communication of well-written prose, of meaningful, thoughtful code. And I thought this was really a bigger design problem, actually. So I've been working on a sentence recently. I know. My job now is that I work on sentences. It's ridiculous. So I've been trying to summarize how I feel about modern software design and this intersection of complexity. And it's this, that I always believe now, my litmus test is the complexity of your application should be at most as complex as the problem space it inhabits and no greater. And it's my universal kind of assessment criteria for like, is this thing the right size? Is this the right design? And macro and micro design are the tools that we have to meet that goal, right? To take a complicated thing and make it simple. And you know what, like so many systems just plain fail that test at the start. They lose themselves under infrastructure and build systems and deployment and modules and reuse and just like all of these grand ideas that people have about how they're going to grow their software that never come to be, right? And actually they stop focusing on the form that the software should take now instead. And it buries systems, It makes working in these kinds of systems like swimming through treacle. I say like I've tried. It's like we forgot how to build small, beautiful things that solve problems discreetly while trying to build like the next #billionaire Web3, who fucking knows, right? Like everyone was focused on big, not small. So the interesting thing about thinking of software as design is that even the use of the word design is a little bit contentious. So it means a lot of things, and it's really easy to mistake for other things. So designs exist to solve problems and to communicate intent using their form and function in a context. But designs are also temporal in nature. They exist in a context of time as much as anything. And a lot of design doesn't make sense when you take it out of time. So there are really great examples of products with great, I hate saying this about this, like period design. That makes me feel really, really old. That are nonsense now when removed from the context that they're in. So there's this really interesting observation. These two iconic designs here, they weren't actually the last of their lines at all. So they evolved and changed over time. And that's because design is iterative. Phones didn't cease to exist. Walkmans didn't vanish. They were iterated out into touch phones and mobile phones and Discmans and iPods. And the irony, of course, is these two completely distinct, different things converged, right? Because we discovered what the real problem was underneath, which was basically they were solving the transmitting audio problem, really. And in fact, the really nice thing about thinking about this evolutionary incremental form of design is that if you look at the processes that we come up with in software development, things like TDD that can be casted as a design discipline, they feature that same rapid iteration incremental process to test and rapidly evolve a design into a good form. And one of the things I'm always totally certain of is all the people that criticize TDD have never actually used it for that incremental and iterative process. They kind of write it as one and done, and all they were really doing was writing a test. It's not the same thing. This also kind of highlights this other magic quality of design as a discipline, which it is that it's just as much about form as it is about function. There are kind of entire categories of problems that, unless you are a much smarter person than I am, you can't fit in your head until you see it. Visual reasoning is a really, really powerful tool. And actually, these design processes and iteration let you see the thing and kind of feel it out and work out whether it feels right as much as anything. And I think, a lot of people kind of feel like programming isn't an aesthetic or a visual occupation. But we look at things all day, every day. And actually, I think it plays into the way that you interact with your software more than you realize. So I don't think it's categorically impossible to, do great design without TDD or without some kind of iterative process. But I do believe it's a lot harder. And you probably need something to replace that iteration with if you're going to have success there. So I kind of took this framing device and looking at software design as design really. It's probably worth us thinking about the context that the systems that we build today differ from when we were originally working on design patterns and pattern languages to see what good looks like. It's kind of worth us reevaluating organizational patterns, for instance, for a modern software context where we are not building modern desktop systems, mostly. Sorry if you probably still are. Programming languages have made categories of problems obsolete, and they have. And, I guess the thing that a lot of the clean architecture folks will probably dislike about this is that most of the things you think of as best practice are mostly just overblown structural design patterns, right? They're just code organization. And they kind of look as silly as a lot of the comedy organized by architectural concept patterns that we opened up with, right? It's just describing where you put stuff. And I see a lot of system designs these days that have been fragmented into microservices. We all know it's about 80% distributed monoliths, but we're just going to go with it. And then all of these individual moving parts of those systems have been absolutely decimated by best practice because large structural designs have been placed upon very, very small moving parts. And what happens is you zoom out and the overall picture looks fine. You're using all the modern conveniences, all the greatest build tools, all the greatest patterns. But when you zoom in, it looks kind of faintly ridiculous. And I was having a conversation before I came here, and that maybe by calling some of these things kind of architectural styles, they sound like a big thing that's meant to encompass a system rather than some language to describe a characteristic of the system that we can use to share ideas with. And I think maybe a shift in language there might help as well. Let me show another example. Now, you don't have to be able to read this, so don't try. Just observe the lots and lots of boxes, right? Loads of boxes. See, that's how you know it's architecture. So this is a class diagram that I generated from a system that I was building that was following some very, very prescriptive, architectural, clean, segregated pattern. But all I see there is thoughtlessness, right? And you can make a bad job of anything, right? And this was a bad job made of a good idea. So this system, which we were in the process of recomposing back into one single logical application, was divided into this huge number of modules, which were further subdivided by architectural feature. So each part of the application is its own web application, depending on a subsequent core logic library, each one, which all depended, coupled together on a series of common assemblies that it's shared with. And then the total cognitive load of you being able to change anything in any of those applications involved you knowing the whole of that system. And some people would describe this as nice and well-intentioned. It's a neat diagram. But the irony here is that whole thing was maintained by a single team of 4 people. And all of those applications were deployed to the same logical server and mapped together into what looked like one application. Bit of a canary in the coal mine there. So the irony is, for all the macro design that people have put in place, the quality of the code was this garbage. It was just tons and tons and tons of copy-pasta garbage across everywhere. People have been so bothered by what the architecture looked like that they forgot to make the software any good. And it was just a case of focusing on the wrong thing, and it was horrible. And I see this everywhere, right? Absolutely everywhere. So how did we spot and fix this? Well, we did a first round of trimming the complexity. We collapsed all the families of modules together. So every web app that had an assembly with business logic shrunk together into one thing. We then, rather than releasing all of those web applications, we just kind of folded them all into the same application. And of course, those web applications had, and I think actually on the next slide, there's some numbers. We started out with 64 modules, 19 build pipelines times 3 environments, and it was taking about 50 minutes to deploy into an MVC app in one repository that all deployed together in one pipeline in 3 minutes. And the code didn't change. We didn't change anything other than we just took away all of the repetitive garbage that was burying the software. And I think this is what the real end game is when you think about structural design kind of running wild in your systems and lots of non-context sensitive designers, you end up with weird stuff like this happening. And the team that were running it were good people. They weren't the people that made the original decisions, but they didn't feel empowered to change it until we kind of said, hey, this is wild, and you're struggling and you're sinking here. And I left them with one piece of advice, really, which is just, build smaller things. Build smaller things. All of these things were obviously one system. So we just made them one system. So there are obviously certain problem spaces where there are known good structural design patterns. That, again, no absolutes, right? Like, there are good answers to some common questions. The most obvious kind of glaring example is in RPC style systems over HTTP APIs. They often map quite well to command query patterns of processing where the logic is all self-contained. But in those systems where you're using known good patterns, actually it makes the moment-to-moment programming in their implementations even more important, because actually it's important to not be code blind and think everything is the same. I suppose what I'm reaching for here is it's not really just what you say, it's also how you say it, right? And it matters because when the design looks uniform, you risk skim reading. And as soon as you start skim reading, you're not actually understanding what your code base is doing. It's dangerous. So the interesting problem with good known reference designs is it's easy to learn a pattern and then decide everything in software needs to look like it, right? You get your mental model and you realize you can cast it onto everything. And the reason I say that is, this is me. I have done this so many times in my career, and I'm hopefully not going to do it again, but you never know. I learned about MVC and I thought everything had to be a controller, right? Just what it was. And then I first learned about aspect-oriented programming, and all I could see was chains of interceptors everywhere and pipelines everywhere. I internalized as a mid-level dev that, controllers only ever HTTP stuff. So then I thought everything was an application service. Interesting. When microservice design first got popular, I thought everything had to be completely decomposed. I made all these mistakes, and the truth is it depends, right? System design is just a series of trade-offs. And it takes time to learn, actually, that uniformity is the opposite of expressiveness. If you're trying to say something, everything sounding the same is actually bad, really. It's important that when the different parts of your software do something different, their form reflects their function. And they don't look the same as everything else in your code base, because that visual variation is a tell. It's something you're giving to the reader. And I guess this is all a bit of a war with complexity, right? It's all tools that we're trying to use to make things feel a bit less scary and feel like there's a good answer. And I guess I feel like intentionality is almost the opposite of complexity. That we should stop doing things just because. We should stop cargo culting design decisions. We should stop looking for that easy single answer that everything is a bleh. If you don't understand why you're doing something, stop doing it. Easy. It's a change everyone can make. Just stop doing things you don't understand. Seems really easy, actually. But especially if you can't justify extra complexity, don't add the extra bit of thing, right? Unfortunately, I think because of so much of software design being so context sensitive, there are many times where blindly applying patterns makes software more difficult to reason about and increases cognitive load. And, we're really trying to stop that. So let's talk about complexity and cognitive load, because I think different people have wildly different definitions of what they think complexity really is. So I'm often a little bit shocked by the kinds of things that people do not recognize as complexity. So there's a great quote here on the screen, and this is from a book called A Philosophy of Software Design by John K. Oosterhout. There's some books and references at the end, don't worry. And I think it really gets to the heart of why complexity is a problem in software. Complexity is anything related to the structure of a software system that makes it hard to understand and modify the system. Right? That's what it is. And the chapter of the book that this quote is contained in basically offers the thesis that complexity is never caused by a single catastrophic error. It's just like the tiny paper cuts that get you over time and the moment-to-moment poor decision-making. And they accumulate from the collection of dependencies, obscurities, and idiosyncrasies of the work itself. So Oosterhout describes complexity as the thing that leads to what he calls change amplification, high cognitive load, and unknown unknowns, subsequently leading to an explosion of work and effort and the number of modifications that it takes to then subsequently implement features and software. So building on that definition, I kind of think that intentional, thoughtful design is like a salve for this creeping wave of complexity. So there's a particularly distressing realization that hits you when you get to this line of thinking, which is that design patterns are precisely as popular as they are because it gives people a way to reach for something that is a known good answer. And they feel good. It's like someone's giving you the cliff notes that says, when someone says this, just say this and you're good. Everything's cool. Don't worry about it. But once you've seen enough code bases and enough languages, you kind of realize that most of the arbitrary stylistic qualities of code that people focus on, everyone now laughs at the tabs versus spaces thing. But basically, a lot of all these other discussions are just as silly. They're just irrelevant, actually. And instead, there are actually a couple of non-negotiable qualities that you look for in a good code base that are far less regimented than like a JavaScript style guide. For me, good code is code that's easy for someone with minimal domain context to read, code that focuses on developer experience, debuggability, and usability, code where the intent, what you're doing, takes up more visual space in the source file than all of the language, guff and orchestration and syntax and all that kind of stuff, where what you're doing is the thing that you see when you open the page. And the truth is, regardless of language or style or intent, all programmers interact with code bases the same way, right? You open it up and you glance at it to see if you can see what it does, and then you read intently to try and understand how it does it. Good code makes that easy. And, at a meta level, all code is constructed from abstractions and encapsulation. They're two very, very common words. And this has always been true. And the programming languages and runtimes and frameworks in which we write higher level code go through like this horrible, enormous amount of compilation and translation and interpretation in order to be executed. Programming languages themselves are just common abstractions over operating system APIs, which are abstractions over assembly languages of microarchitectures, which are abstractions over physical hardware. Like we're built on top of this massive stack of stuff. And actually, that trend continues into the functions that you write and the types you define and the classes and files that make up your application. And the good news is, for the most part, we don't have to worry about any of that shit, right? Like we're blissfully unaware of it. And I always like this single example that you never really worry about file open. Like file open is almost a perfect API. But actually, if you really think about the complexity of the system that exists underneath it, it's massive. The truth is, when you implement your own systems, that sadly that same depth of implementation is never true, or is often untrue. And I'm going to borrow a little bit more terminology from Oosterhout's book when we think about this example of file open. So if you think of a module in a piece of software, this could be, when I say module, I mean a package or a class, depends on your programming language really. The interface that it exposes represents the complexity that module imposes on the rest of your application. So the broader the interface, the more methods and functions and parameters, the more complexity your application is exposed to. The smaller and simpler the interface, the less complexity it forces onto your application. And the reason behind that is there's literally more stuff that could be happening when you interact with that module. And by that description, file open is a beautiful, deep module because the surface area is very, very narrow. File names, paths, byte streams, or text on the way out. Every language, it basically looks like that. But what it does is it abstracts over file systems and spinning disks and operating system APIs and SSDs and God knows what else, right? Very, very deep, contains lots of functionality, but very, very narrow at the top, very, very tight API. If we understand that to be true, and that contains complexity, so deep module's good, the inverse is then also true. That anything with lots of parameters, lots of functions, lots of potential, actually, might not be offering much benefit to the calling code above. It might be making things worse. And it doesn't help because then when you're interacting with that code, you have to comprehend all of those possible options, and it makes your software more complicated. And as much a factor of avoiding the wrong abstractions like that is finding the right ones. So it might seem like really painfully obvious advice, but abstractions and generally any other module of code that you find should contain a problem space entirely. And I think this is you say that as a sentence and everyone nods along, but then you think about the number of things you've written with pass-through interfaces and functions that have no behavior. And it becomes like really, really apparent that even though we kind of believe this to be true, we do lots and lots of things that counteract that. Pass-through interfaces, for example, add nothing. And all they actually do is they take the complexity of the thing they're passing through to and pass on that entire complexity to the consuming code. So they're, by definition, bad design. It's a thoughtless abstraction. It's poor encapsulation. And every time a decision like that is made, it decreases the reason that a module exists. It decreases a reason that that piece of software exists. So by definition, we now have kind of a metric to understand why that is bad design, why anything that adds boilerplate code is bad design. Because what we're doing is we're passing on the complexity of lower order modules up into our user code that we have to deal with every day. So you get to a certain point where you realize that all this talk about design kind of dissolves into a discussion of like dogma and absolutism. Because, and I said this yesterday in the keynote, there's an absolute truth here that any design, when stretched to its logical absolute extreme, just becomes nonsense, right? It doesn't matter what it is. You can make any good pattern sound stupid if you put it in the wrong place. So designing software with intention, software that survives, is kind of an exercise in compromise, always, and of trade-offs. It's why anyone with experience in designing systems always kind of gives you it depends. And it does depend. And it's better if we talk about what it depends on. In fact, a lot of the poor trade-offs that I see in software involve people actively not understanding the sources of complexity in their system, not understanding the depths of the modules that they're building or the interfaces they're imposing on the software. There's a really good example here of taking on extra dependencies like packages, right? You're effectively then on the hook for the surface area of that API in your system because subsequent changes could use extra functionality there and things become more complex. There's a lot to be said about maintaining 30 to 100 lines of code that you wrote rather than taking a dependency on a 42,000 line dependency, right? You know what it does. You may have the cost to change it, but you don't have to deal with managing the rest of that complexity. And it's interesting because it's kind of an unhealthy bedfellow with this notion that you should never write code that you don't have to, right? And actually, so a real practical example, I recently lost an entire weekend of my life researching what the state of the art in static site generators to take some markdown files and put them on the internet was. And I got to the end of 2 days of trying every web framework under the sun. And I wrote a 200-line program. And I just shipped that instead because I knew I didn't need any of the features. And I figured if I adopted framework of the day, I'd then be hooked to its maintenance line and all the changes and all the breakages and the security patches. There's a lot to be said about just owning your own shit sometimes. And it was precisely just because I didn't want the cognitive load. All your designs should really be expressed with that kind of trade-off, right? What I was really doing, the process I went through was I said, what features am I looking for? Mark down into HTML. I can write that with one library that calls one function and never think about it again. Cool, sold. I understood why. And in fact, once you start considering your design as this series of continual trade-offs, what you realize is that instead of rules around system design, what you end up with is kind of tests of your design. I don't mean coded tests. I mean just tests we use to evaluate the qualities of the systems that we build. So I want to take you through a few tests that I tend to use whenever people bring me designs, whenever people on my teams talk to me. Could this be done with less moving parts? Right, and this is always hard for people because they often think, well, microservices, more moving parts, better because resilient and scalability. But every moving part you add is actually a repository, 3 build pipelines, some security scans, some static analysis. Like there's just that extra total cost of ownership in every part that you put into the system. So if I can do something with less, I will. And by that same token, I won't just arbitrarily pull out any single capabilities and extract them to common dependencies just because. Until someone really, really needs that thing, I'm not going to do it. Break up systems into individual components only when they need to ship, scale, or deploy independently. Is this operable in a production environment? Software that's hard to observe, deploy, and manage slows the pace of change. And the only thing I can promise you forever and a day is your software will change. So you should always optimize for the thing that I know with certainty will happen. Software that's difficult to change is basically dead on arrival. And that's the same point in a different slide. So what I'm really advocating for here when I plead for intentionality is for you to write your code with kind of care and purpose. I want you to think about the design of your software. I want you to think about the reader. I want you to think about the form and the flow of your application and what they tell the person that's reading it next. I want you to use all the forms of expression available to you in a code base to communicate meaning and intent. One of my almost hills that I will die on at the moment is people keep on misinterpreting this and saying, oh, you can just use linters for all of this and auto formatting fixes this all. And I kind of have this fundamental belief that auto formatting is taking a piece of the programming process where you can express something to the reader and giving it to a machine with no context and hoping it does a better job than you will, which seems absolutely inane to me, completely asinine. I think, it's important to remember that different problem spaces and different solutions require different aesthetic viewpoints. And we should embrace that. There shouldn't be one language style. Right? It should be context sensitive, lest we damn ourselves to everything either being a jumble of components full of HTTP calls. That's one of the big meta designs, or an MVC app. The two true designs, right? It doesn't have to be that way. And when we use form and design to telegraph intent, your work becomes better because your care shows. It shows that you've thought about it. And I love that about things. So I was on this podcast a couple of years back where I was asked what advice I would give myself at the start of my career. And the answer is really, really clear to me now. I'd take more time with everything. And I think all of the best designs that I've ever committed, all of the things that I've given to people where people have sent me messages afterwards and been like, oh, that's really, really cool. I'd finish the thing. And I'd sit in an evening and I'd pour myself a drink and I'd put some music on, I'd just read it. And I'd mull it over and I'd ask myself, why? Why did you make that choice? Why did you call it that thing? It's almost like a code review with yourself, with your both harshest critic and kindest friend, right? And if I couldn't articulate to myself why I've made the decisions I've made and picked the names I picked and structured things in the way, if I couldn't say what that was telegraphing, I would change it. Sometimes I'd back it out. Sometimes I'd commit to it. It was okay. But that extra bit of care, that like 20% of extra time to really sit with the work was what made all that software good software. So that's what I would do. That's what I would tell myself. Take more time. So I want to leave you with a few reading recommendations, partially because there aren't really a lot of books on this topic. Like, it's not really the way people think about software design. So A Philosophy of Software Design by John Oosterhout is excellent. Please, please, please read it. Your Code as a Crime Scene just had a V2 revision, came out yesterday, I believe. So it's about 10 years old, by Adam Thornhill. Very, very good. Mark Seaman just put out Code That Fits in Your Head, which is a lot about the moment-to-moment aesthetic choices of how we express things in code. Also, Kent Beck just put out a new book called Tidy First, which is a really, really concise read. It's like a 3-hour read. Absolutely brilliant if you want to go through like some examples of how you can change the aesthetic viewpoints of your code. They obviously contain way more exhaustive examples than they can fit in a presentation, but I really would recommend them and support all the authors in our community, obviously. So yes, this is the talk. Fuck it, it depends. That would have been put on the agenda if they'd let me. So yes, I like talking about this stuff. I hope maybe this has been some food for thought as how you can change the way you work. Thank you for coming. Any questions? I saw you all go to clap and then I interrupted you. There we go. Thank you. I see silence. I love it. Please.
Is things improving or getting worse over the years in this space?
It's difficult.
There's a lot of thought about it, I think, these days. But
I think on balance, things are improving. But I think it's been a particularly precocious 15 years for it. In that I think I've had a number of conversations about this while I've been out here this week, actually. I think there's a truth that a lot of back-end development stabilized quite well with rational tool chains. It then suffered from like a middle era, a big, fat, bloated over-design as we stumbled towards answers. I think some universal truths have started to become apparent that have taken some of the bite out of that. I then kind of think front-end turned up 15 years later and went, you know what we're going to do? That exact same 10-year arc, right? And I think actually, and it's cool, and it's because we pushed all the complexity into the front end, right? So front end people then had to contend with the same problems that we've been contending with ourselves, and they learnt the same lessons with slightly different aesthetic viewpoints. And I feel like we're kind of all coalescing onto a similar kind of problem space. And you kind of see it. You look at tools like, I think, front-end tool chains are a really good example of where this has been going because they started very duct-taped together for years and years and years. And in the last 2 or 3 years, a lot of things are kind of coalescing into smaller 2 or 3 tools, and that's it kind of tool chains, which I think reflect where back-end development has been. And when you see kind of modern languages like, I don't know, we'll pick Rust as a random example, a lot of the things that used to be glued onto the side of all of this are now kind of core to the language and the compiler tooling that comes with it. So I think that's better. I think microservices got misinterpreted for a very, very long time. Microservices are awesome, by the way, legitimately awesome. But what most people built was weird codependent spaghetti nanoservices. And now people are going, oh, monoliths are good. Why? Well, because we made a big pile of shit over there. And it's like, cool. But you made a big pile of shit in the monolith before you did that as well. So it's not like this is any different. I think the truth is, as we get better at talking about these things, we'll see the line go up. And I think that's probably good. And every time we do that iteration, we learn a little bit more and we get better at explaining it and we get better at understanding it. So I'm hopeful.
Hello. Yeah. I had a question. So if you walk into a code base that is suffering from being very complex, but you're tasked with something else, implementing new features, whatever it is, how do you leverage your itch to reduce the complexity with your duty to work on the work you were tasked with?
So one of the hardest core skills of a programmer is this. Someone gives you a ticket to do and you open up something and there's a load of shit in there, right? And everything in your gut says this has to change, but you've got to do the work. If it's going to take less than 2 hours, just do it. Just do it. Please just do it. Because if you don't do it, someone will be mad later. And that's exactly the same thing I say to like all my teams. If it's going to take you kind of less than a morning to fix something, I don't want you to tell me about it ahead of time. I don't want a ticket. I don't want to have a conversation. Just fix it. I trust you. You're professionals. I would never go to a doctor and say, hey, buddy, we're going to do open heart surgery. Don't worry about washing all that stuff up. Just get me in and out, straight in there. So I think there's kind of a professional responsibility to take care, but equally, once you hit a certain inflection point, a professional responsibility to write it up and say, okay, we've got an actual problem here that we need to solve. Let's talk about it as a group. And I think finding that balance depends from organization to organization and from team to team. But I tend to feel that healthy teams chip away. It's the same thing people have been saying for years with the Boy Scout rule, right? Leave the campsite better than when you arrived. But it just takes that discipline to know when not to ask for permission. Can't tell you.
Love this. It's made me question about 10 years of my career, though.
Sorry.
That's all right. It's not the first time that's happened. This a lot of the self-reflection about how much complexity you're introducing and stuff kind of relies, I think, on having the experience to know whether you're just following the patterns that your team has done. And what advice would you give for junior devs who maybe don't have that experience?
So it's really interesting. And I was having another conversation a couple of days ago to someone else's talk about how it's very, very difficult when you don't have experience to understand trade-offs because you're not really sure what you're trading off. Now, my mental model is this. Every program has context. It has scope, right? There's the number of variables, the stuff you got to think about to make a change. As you start to clean things up, anything that reduces the amount of scope you have to hold in your head to produce a modification is good. Anything where you take that entire context and shift it somewhere else is bad, because actually you've not reduced anything. You're picking up all the context. And it's the reason why a lot of refactorings where people, and actually one of my core criticisms of clean code is there's lots of examples of refactorings in there where it's extract method, extract method, extract method. And all those methods required the exact same amount of context as the parent method to reason about. And actually what that does is as you're reading that top level function, you look at it and you're like, well, anything could be happening in there because I'm passing all of this stuff over there. And that's actually worse for cognitive load rather than better, because then actually you've got what you see and then a potential avenue of risks. So my one, the one bit of advice in the middle is be mindful of the amount of context you are passing around, because the bigger the context is, the riskier operations can become. Good workout.
Sorry to make you run, mate. So it's interesting, all those organizational patterns that you talk about, there's a certain, I guess, irony in that a lot of the reason that we apply those was with the goal or intent of making things,
more accessible and more predictable, right?
Making it, easier to reason about, making it easier to maintain. So a lot of the stuff that you talked about here, I get it conceptually, but the devil can be in the detail, right?
Always.
So when you go to apply this, how do you actually translate that? Do you have like a checklist of look for this, look for this, look for this? I think it's easier to learn through examples.
Yeah, I agree.
So I guess I'm just wondering, do you have a couple of GitHub?
I do have some examples that aren't in here. What I would really, really recommend if you're looking for that, pick up the Kent Beck book, Tidy First.
Right. And
because it is literally just a catalogue of examples. And I think the really interesting thing that he does in that book that's different from maybe previous, because ultimately it's a refactoring book, right? But the opening section I thought was quite illuminating. He basically said, we fucked up the word refactoring, right? Because refactoring can mean rewriting, changing it's meant to mean changing the form, but not the function, right? Very, very obvious. But 20 years of misunderstanding that means that it's become meaningless. It's like saying integration test doesn't mean anything anymore, right? Meaningless terms. So he's using the word tidy, which I thought was quite cute, but also it then becomes a dictionary of tidying up examples of here's something ugly, clean it up in this way. Hey, there's a couple of patterns merging things together to then tidy them and separate them out. So pick up that book. It's amazing. Would recommend heartily. Any more? Please.
Sorry. Thank you, David. It was a really great talk to start with. But as software devs, we all have pure intents, right? No one's here to destroy the coding world. And my question is, when you have a code base and you have conflicting priorities, I think that's probably a challenge every one of us faces day to day. You have a timeline staring it down at you, and then you have a code base which is spaghetti, basically. So where do you draw the line of when do I clean up and when do I
wait till later? And that's, funnily enough, that's the other half of that book is about when. And when is just as big a question as any. I think my personal line is anything I can do with tool-assisted refactoring in less than a second, I just do. There's no excuse, right? Like it's kind of known safe. Anything that's more structural and foundational, you should think about and schedule and prepare for, because actually it could be more dangerous and more disruptive. A lot of this stuff, and again with the it depends theme, depends on the size of the code base. If you've got a code base that's up to like 2,000 lines of code, 5,000 lines of code, the time is now, always. Just do it, right? You can meaningfully sit there for a week and read every line of it and fix every line of it. Just do it. When you're in the hundreds of thousands of lines of code and big old, maybe legendary old systems that are big and running, be careful. Cut bits out of cut complexity out of the middle of the system. Work on the piece in isolation. Put it back in. It's a bit of a trade-off, and the truth is, you're the best person to know what you think is scary and what you think isn't. I would give the same advice I give to all my teams: is be brave. You have source control. Just revert it if you fuck it up. Don't worry about it. Just code.
So you have a legacy system, and then you get offered, you can either use one of the enterprise solutions that you can replace that system with the enterprise solution, or you can write it in a cloud native environment. The business wants to go the enterprise solution because it's quicker. It's already engaged in part of the business, but as an engineer, you want to go cloud native because you have more control and all this. What do you recommend?
What would I recommend? Well, I think I always caution people against rewriting systems. I think rewriting systems is fundamentally a dangerous and narcissistic act most of the time. It's just you saying, oh, this isn't my mental model. Fine. I've always suggested that systems should be evolved into the systems you want them to be. So I would take that enterprise system and look at how you could increment out parts of it to be cloud native. Maybe, and again, this is a contextless example, maybe you could deploy the enterprise system twice, once to the cloud, and the portion of it that you want to trigger in the cloud is the only bit that is invoked. You still have one unit of code, you're still maturing the same system, but you're subtly migrating it between places in a way that's compatible in both senses. I would always recommend backwards compatibility, because that stops you from making mistakes. Well, it doesn't stop you from making mistakes, but it stops you buying the farm when you do, Awesome. Thank you so much, everyone. I hope this was interesting. I know it's a bit cerebral. Thank you.